If you tighten the cables inside a flyover, how does that tension actually increase its load-carrying capacity? To understand this, we must first see how a flyover transfers weight from vehicles down into the ground. The total weight of the structure and traffic moves through bearings into the piers and then into the deep foundation below. Engineers begin construction by searching underground for a strong and stable hard rock layer. If the entire structure rests on this hard layer, the flyover becomes extremely stable and long-lasting. Once the strong layer is found, steel reinforcement bars are inserted deep into the drilled shafts. Concrete is poured carefully into these shafts to form the foundation piles. After proper curing, these piles are ready to carry enormous forces safely into the ground. If piles fail to reach strong ground, the entire structure becomes vulnerable and unsafe. All foundation piles are connected at the top by a massive concrete block known as the pile cap. From the pile cap, vertical piers begin rising toward the future road deck. At the top of each pier, specially shaped pier caps are constructed to support the superstructure. Now comes the most important structural element, the box girders. These girders are prefabricated concrete segments produced in controlled fabrication yards. Steel reinforcement cages are placed inside molds before concrete is poured. After curing, the internal formwork is removed, revealing hollow box-shaped structures. These hollow sections reduce weight while maintaining excellent structural strength. On site, a massive machine called a launching gantry assembles these segments in the air. This gantry moves forward step by step, assembling one span at a time. Each segment is carefully lifted and positioned between two piers. Epoxy resin is applied between segments to create a tight and durable joint. Small gaps are intentionally left to allow precise final alignment of the last segment. Once aligned, reinforcement bars and concrete close the final connection. Now comes the most crucial stage, inserting high-strength steel tendons through internal ducts. These tendons are stretched using powerful hydraulic jacks to create extreme tension. Even if temporary supports are removed, the segment remains stable after tensioning. But are these cables only holding segments together? Not at all. Without post-tensioning, cracks would eventually develop at the bottom of the girders. Concrete performs very well under compression but poorly under tension. When a beam bends under load, its bottom surface experiences tension. If untreated, this tension would cause cracking and structural weakness. Post-tensioning compresses the entire concrete beam before service loads are applied. This pre-compression counteracts the tensile stresses caused by traffic. As a result, cracks are minimized and durability dramatically increases. Hydraulic jacks stretch the tendons and lock them in place using specially designed wedges. These wedges grip the cables and prevent them from retracting. Even after removing the jack, the cable remains permanently tensioned. This clever mechanical locking system keeps the structure compressed for decades. Just a few high-tension steel cables can dramatically increase structural strength. At the ends of the flyover, structures called abutments connect the deck to the ground. Soil is compacted behind the abutments to allow smooth vehicle entry. Large interchanges are carefully designed to control traffic flow efficiently. Different interchange types are selected based on traffic volume and land availability. Expansion joints are installed between long segments of the flyover. These joints allow the structure to expand and contract with temperature changes. Without expansion joints, thermal movements would cause severe cracking. The deck rests on bearings that allow controlled horizontal movement. Together, bearings and expansion joints protect the structure from environmental stress. Some flyovers use steel girders instead of concrete to reduce construction time. Steel structures are lighter and faster to erect but generally more expensive. In the end, every flyover is a combination of soil science, structural mechanics, and precision engineering. And at the heart of its strength lies one invisible force: controlled tension inside steel cables. That hidden tension is what allows millions of vehicles to pass safely every single day.